Today's lesson is on graphing inequalities. The LEQ is how do you graph inequalities on a number line. You will be introduced to three new vocabulary words: inequality, algebraic inequality, and solution set. An inequality is a mathematical sentence that shows the relationship between quantities that are not equivalent. When we are comparing quantities that are not equivalent, we use comparison symbols, such as less than or equal to, greater than or equal to, or not equal to. An algebraic inequality is an inequality that contains at least one variable. You see these algebraic inequalities in several forms. A solution set is the set of values that makes an algebraic expression true. When you plot an algebraic inequality on a number line, it is very easy to see that the variable can be represented by quite a number of different numbers that would satisfy the inequality and make that statement true. Let's begin with an easy one. X is less than 2. If we're going to put this inequality on a number line, we select the significant number that x is being compared to, which is the 2, and we see that it is less than, but it is not equal to 2, so we put an open circle on the 2. Then, all of the values for x that satisfy this inequality are less than 2. So we draw a solid line down the number line to the left, showing that all the values that are smaller than 2 would make the above inequality a true statement. The open circle means that the number 2 is not included in the solution set. Think for a moment if you did replace x with 2. 2 is less than 2 would be a false statement. That is an easy check to see if you use an open circle or a solid circle. Our next example is x is greater than or equal to -7. When we put this on a number line, our significant number that we're comparing x to is -7, and this time we will use a solid dot because x is greater than or equal to 7. Now, for the solution set, we need to include all the numbers that would satisfy the requirement of x being greater than or equal to. So we draw a solid line going to the right, showing all the numbers greater than -7, which would, in fact, make this a true statement. What if you have an inequality and you want to graph the solution set? For instance, -4 is less than or equal to x, and x is less than 7. We begin by taking the two significant numbers that x is being compared to, and we look at the sign to see if it is equal to this -4 or not. In this case, x is not equal to 7. It is less than 7. So we put dots on our graph that show that x could be equal to 4, is greater than or equal to 4, and it is also not equal to 7. Now we know that x is bracketed between these two values, so we draw a solid line between them, and the solution set now lies between -4 and 7, inclusive of the -4. Another example is 3 is greater than x, and x is greater than or equal to -3. Again, we put the two end numbers on the number line, -3 and 3. The solid dot goes to the -3 because x is greater than or equal to -3, and it is an open dot because 3 is greater than x. So, in between these two numbers, we find our solutions to this inequality. So the solution for x could be anything. It could be -2.5, it can be a -2, a -1.5, a -1. It could be 0. It could be a positive 2.5. There are many, many solutions for x along that number line. Suppose you have a graph of an inequality and they have asked you to write the algebraic inequality for the solution set. We do this in a very similar way to the way that we just put the graph on the number line. We start by taking the two significant numbers that we are going to compare x to, and we see that x lies between these two numbers. Ignore this symbol. I think it's just an extra thing on the slide. Okay, so -8 is on the left, and 3 is on the right, and x lies in the middle. The relationship between -8 and x is that x is larger than -8, and -8 is not equal to x. So we're going to put -8 is less than x. And that satisfies this portion. Now, x has some relationship to 3, and if we look at the 3, it could be equal to 3, and it's also less than 3. So we're going to put the symbol for x is less than or equal to 3. And we have constructed our algebraic inequality. The second example, we take the two numbers that bracket the x, a -6 and a 5, and we know that x lies along this line at any point. Then we look at the relationship between -6 and x. You can see that -6 does not belong in the set because of the open dot, so it is not equal to x, but x is greater than, or we could say it as, well, -6 is less than x, so we'll put a less than sign there. And then we look at the relationship between x and 5, and we see that x is less than 5, and it is again not equal to 5, so we put the sign x is less than 5, and we have constructed our inequality and graphed it.